We will start by defining the domain of the boundary value problem. In this case, that is the fluid region inside of the microchannel structure. With Workbench open, start by dragging Fluid Flow Fluent with Fluent Meshing into the project schematic. Rename it Microchannel Flow to help with organization. Then, double-click on Geometry to open Discovery. Once Discovery has opened, click the coordinates in the bottom right corner of the screen. This allows us to update the units for the current file. Start by changing length scale to small. This allows us to change length to nanometers. This is the most suitable for our geometry. Next, select Sketch if it's not already selected. We want the symmetry axis of our microchannel structure to be the z-axis. The default sketching plane in Discovery is the XY plane, which is what we want. So we can press the V key on the keyboard to look at the plane. If this does not make you face the XY plane, you can choose a new sketching plane by selecting the New Plane option and clicking on the Z-axis. To begin sketching, select the Circle tool in the top left. Hover your cursor near the origin until it is highlighted green, and left-click to begin creating a circle. Move your cursor outwards, and click to create the circle. Repeat this process again to create another larger circle. Clicking the origin means that these circles have their location constrained. Their dimensions, however, are unconstrained. We can fix this with the Dimension tool in the top bar. Click on the inner circle, and click again to create the dimension. Do the same with the outer circle. We can now click on the dimensions to edit them. The outer radius of the flow domain from the problem statement is 150 nanometers. We can see from these lines, however, that the dimension is set to the diameter of the circle. So click on the dimension for the outer diameter, enter 300, and click Enter to set the outer circle to the correct size. To see this, we can zoom out. Similarly, click on the dimension for the inner circle and enter 140 to correspond to the specified 70 nanometer radius, and click Enter. With both circles fully constrained, we can end our sketch by clicking 3D mode in the top bar. Looking in the tree and expanding Design 1, we can see that this has turned our sketch into a surface. We want to use this surface to create the solid annular flow domain. To do this, select the Pull tool in the top bar if it's not already been selected. Use the middle mouse button to reorient the model to a more standard view. Click on the surface to select it, and click and drag the yellow arrow to extrude it to create a solid. Let go of left click and enter 500 to extend the length to 500 nanometers. And click enter. Finally, click escape on your keyboard twice to exit the tool. This gives us the complete flow domain. Next, we want to add obstructions into the flow. Since the solid geometry we are modeling represents the fluid region, these obstructions will be created as holes in the shape. To start, click Sketch to create a new sketch. Hover over and click on the Y-axis to begin sketching in the XZ plane. And press the V key on your keyboard to orient the view to be facing this plane. To start sketching, click the Circle tool. Hover over the Z-axis so that it is highlighted green, and left-click to begin creating a circle. Move your cursor outwards, and click again to complete the circle. Next, we can constrain the geometry using the Dimension tool. Start by selecting it in the top bar as before. Click on the circumference of the circle to begin creating a dimension. And then left-click away from it to set it. This allows us to constrain the size of the circle using its diameter. Click on the dimension to edit it. Enter 10. And click Enter on your keyboard. This sets the diameter of the circle to be 10 nanometers. Next, we want to constrain the location of the circle. It is already constrained to lie on the Z-axis, so we just need to indicate its position along that line. To do this, with the Dimension tool still selected, click on the edge of the circle, and then click on the origin. We can see that this is going to create a dimension for the distance between the circle and the origin. So left-click to create it. We can then click on the dimension to edit it as before, and enter 150. This moves the circle to its desired location and fully constrains the sketch. With this complete, click 3D mode as before. We can use this new sketch to create an obstruction. Using the middle mouse button, click and drag to rotate the model so that you can see the new circle inside of the geometry. Once you can see it, select the Pull tool if it's not already been selected. We can then hover the cursor over the center of the circle so that its area is highlighted, as shown here. And left-click to select it. While we previously used the pull tool to extrude a sketched surface to create a solid, we can also use it to cut through an existing solid. Click the two arrows in the selection options and select Cut. We can then zoom out slightly so that we have enough room. And we can then click on the yellow arrow and drag it all the way through the geometry. The exact length of the pull doesn't matter. We just want to make sure that it cuts all the way through the geometry such that we can see a hole on the outer surface. Using the middle mouse button to rotate the view as before, we can see this hole more clearly. This creates an obstruction in the flow domain. Press Escape twice to exit the tool. We want to create the same obstruction at two other points at the same axial distance. While this can be accomplished in the same way as before, by sketching circles on two different planes, it can be accomplished more easily using the pattern tools. To start, select the circular pattern tool under the Create options. Next, use the middle mouse button and the scroll wheel to zoom in on the obstruction. Hover your mouse near the obstruction until the inner surface is highlighted, and left-click to select it. This is the surface we want to pattern along the geometry. We can then zoom out to view the whole domain. Next, in the options next to the selection, we can enter how many copies of this shape we want to create. Change circular number to 3. And leave angle as 360. This means that the created pattern will have 3 instances of the selected geometric feature over a 360-degree range. The pattern tool needs to know which axis to create the circular pattern around. Ensuring that you can see the whole flow domain, hover over the dotted line in the center of the annulus and click on it to select it. This allows us to see a preview of the pattern on the model, with these small circles representing where the new obstructions will be placed. This looks correct, so click on the green check mark. Press Escape to close the tool, and use the middle mouse button to rotate around the model to see that we have created 3 obstructions successfully. The Fluent interface does not allow us to click on boundaries to apply the desired boundary conditions. This means we need to set up the locations on which these conditions will be applied now. We can do this using named selections. Start by selecting the Named Selection tool on the bottom right of the Discovery interface. First, use the middle mouse button to rotate the view to look at the annular face closest to the origin. We can see the origin at the center of the annulus here. Click on this face, and in the Name Selection pop-up, click New. This creates a new named selection for this face, which we can name Inlet. Next, use the middle mouse button to rotate to the other side of the model. Click on the other annular face, and create another new name selection, this time called Outlet. Next, we can select the outer cylindrical face, as shown here. Click New, and name it Wall Outer. Similarly, we can select the inner cylindrical face, click New, and name it Wall Inner. Finally, we want to select all of the faces of the obstructions and add them as a single named selection. In the design tree, click on Pattern. In the view, we can see that this highlights all of the cylindrical faces of the pattern. Without selecting anything else, click New in the Name Selections window, and name this Wall Pillar. With the geometry created and the named selections applied, we can close Discovery. Back in the Workbench interface, we can save the project in the desired location.